these properties of being one-to-one and onto actually behave pretty nicely when it comes to compositions of linear transformations. So suppose we have two one-to-one transformations. So suppose T from, say, a subspace V to a subspace W, and maybe S from a subspace W to a subspace, say, U. And suppose they're both one-to-one. It seems like a sensible guess that maybe the composition is one-to-one. So let's figure out, is S composed with T one-to-one? Well, remember, to check that, we would just take or assume that we have two vectors, V and W, that end up in the same place when you hit them with S composed with T. And what we want to show is, sorry, there should be W here. What we want to show is that V is actually equal to W. Well, this is S of T of W, sorry, of V. And on the right we have S of T of W. And it's true that we have both linear transformations here, but if you squint so that the stuff inside of S gets kind of blurry, what it looks like is S of something equals S of something. But remember, S is one-to-one, so these two things inside the parentheses have to be equal. That's what it means to be one-to-one. So this means that T of V has to be equal to T of W. But T is also one-to-one, so if T of V is equal to T of W, that means V is equal to W. And now we're done. We showed that if S composed with T, if two outputs are equal, then the inputs were equal. So S composed with T is indeed one-to-one. All right, well, it seems like a good guess that if it worked for one-to-one, maybe it works for onto. So let's suppose that T from V to W and S from W to U are onto. Is S composed with T, which goes from V to U. Is this onto? Well, how can we check? Take something in the target space. So let's take U in our target space, which is capital U. Okay. Well, it's true that U is the target space for S composed with T, but U is also the target space for S. So since S is onto, there's some vector W sitting inside of capital W so that S applied to W is U, right? This is because S is onto. But W, little w, is in capital W. So since T is onto, there is some vector little v in capital V so that T applied to little v is W, right? Because T is onto. But then, what is S composed with T applied to V? Well, this is S of T of V, but T of V is W, so this is S of W, but S of W is U. So you can see we took any vector in our subspace U, we found something in V that gets sent to U. So that means that this composition is indeed onto. Yes, so no big surprise there. Something that I should warn you about is that these don't mix. So if you have two transformations that are one-to-one, their composition is one-to-one. If you have two transformations that are onto, their composition is onto. But if you have one of each, it's possible that the composition is not one-to-one and not onto. So on the other hand, it's possible that it is. So If you have a mix, there isn't really anything you can say about the composition being 1-to-1 or onto.